Hello. So today we are doing this problem called buy and sell stacks. And the problem says we have an array for which the ith element is the price of a given stack on day I, and we are only permitted to complete at most one transaction, which is buy one and sell one share of the stack. And we want to design an algorithm that allows us to find the maximum profit. Okay, so, and the note here that you cannot sell a stack before you buy one. So let's see, how can we solve this problem? So we have an array, and the ith element is the price of a given stack on a day. So 7 is the price of a stack on day 1. 1 is the price on day 2, and yeah, all the way until the end. And we can complete only one transaction per day. So we can only buy one and sell one shares of this, and sell one share of the stack. And the goal is to find the maximum profit we can find here. So we can't like buy two and sell two and have two profits and then add them up. No, we can just buy one stack and sell one stack. That's the condition here. And so for this case, we can buy on day 2, which means we can buy a stack 1 and sell on day 5 here at the price of 6, which would mean we will have profit of 5. And notice the day has to be the day where you buy, the day where you sell has to be after the day where you buy. So you can't say like, I'm going to sell at 7 and buy at 1, because you have to buy it first and then be able to sell it. And since there is no day before 7, you can't really sell 7. Okay, so that's the logic here. Now, how can we solve this problem? So you notice here what we need to do is kind of find the lowest value in the array, which is, for example, in this case 1, and compare it with the days that after it. Which one of them would give us the most profit? For example, in this case, it's 6. So just keep iterating and finding the lowest value. And once you have a lowest value, keep comparing to find if you find lower, but also keep checking if the price that the new price that if you sell your stack that you bought at the lowest value, if you will get a max profit from that. So we can do that in one pass. There is of course a solution where we can just take a stack and try all the rest of the elements after that to see if we can sell that stack and have max profit, but that one would be O(n) squared. But we can do it in O(n) by just doing the following. So basically we will go through the array, and as we are going, we will keep updating a low value and keep updating a profit, which would be just a low, the current price minus low. And at the end, we will keep trying to get the max from this profit, and that's about all we need to do here. So we'd have a low and profit, and the low needs to be just the max in, so that so that it's so that when we get them in with any other value, we'll get that other value, and then profit starts out at 0. And then we'll go through the prices and try to check if we found a new low value. And we will update the profit if the value is bigger, the new profit is bigger. So max profit and basically price minus low. And at the end, just return profit. Okay, so that passes. Now we can do this in another way using dynamic programming. So with dynamic programming here, we have so what are the choices here? You can either in one day you can either rest and not do anything, or you can sell, right? The other alternative is you could not do anything still, or buy a stock, right? So you can either buy or sell or do nothing. Those are the choices that you have. And I'm separating the sell from the buy here. So in that case, so we can have two tables, one for rest and sell, and one for rest and buy. And so actually it's not a table, it's just a value, the DP value. I could have a table, but since it's just relying on the previous value, then it doesn't matter. So, and we can have this is the min, and basically we go through the list of prices, and let's update the values of these two. So what does rest and or sell means? So if we are not doing anything, we are resting, then it's just this value, the previous value. Now, if it's buying, if it's selling, then we need to have both before, right? So to do that, we need to have this. So that's why we have two variables here, because this one selling relies on having bought something before. Now, if we sell, then we get the price. And if we buy, though, then we can either not do anything, or we could buy with price. But buying means we kind of have minus the price, because we are getting out of our profits, so that would be minus price. And this is basically just so that it can help us next time when we sell, right? That's the whole reason of having this variable. And we can return this, which is the main thing that we want here, is having a profit after buying and selling, which is this variable here. Okay, so that passes. So using this previous solution that I did, we can make it shorter. So if I go back to the previous solution, which was here, so with this solution, we can make it shorter. So it's just going through the array prices and keeping both min, and always doing the price minus the min, right? And taking the max out of all of these. So instead of doing this, what we can do is we can use reduce, which is a function that allows us in Python to just apply a function over and over on an array or a list or a sequence and aggregate the result. And so we could apply it here so that we keep aggregating using min and doing aggregating using max over that min, price minus that min, or each value minus that min, basically. So we could do lambda and have a value here. So this would be mapping, actually. So this is the function that we will use to reduce. And what do we need to do? So we want to do max. So we just need to replace these values. So what is profit? I'm going to pass profit as just the value in. Okay, let me first. So we need to do this. I'll replace the value for profit later. But we need to do this on the array list prices. And here reduce needs to be passed the initial value. The initial value in our case here is the min, the lowest value, and the profit, right? So that would mean it's 0, which for the profit, and low, which is float in. This is the initial value. Now prices and this value, that means that this lambda here gets the parameters profit, which is this 0, and then low, which is this value, and then the price value. So V here is represent, in our case here, V is basically equivalent to profit and low. So basically this means that V0 is profit and V1 is low. And so we could just replace that. So this is V0, this is V1. So that's the max. Now what is the min? So we want to aggregate, keep aggregating, and keep finding the min and keep finding the profit. So this is the profit, we already found it, and the initial value is this. Now we need to find the min, and the min is just min of low and price, right? So price is this here, right? So we could just make it p instead to make this faster. And so it's min of low and p. What is low? Low is v1 actually, as we established here. And basically reduce will return us when after we go through the entire prices, it returns us the final value of profit and the final value of low. But we are interested only on the final value of profit. So we just need to get that by using get the zero index, because profit is the one at zero index, as you see here. And that should do it. Okay, just to make this be a tuple, or a pair, sorry, a pair, and can get rid of this. Basically, often when you have an array, like a for loop that is doing some accumulation or some aggregation, then you can replace it with reduce. So let's submit this. Okay, so that passes. I can make a different, use a different approach. This is just for illustration and for like having fun, but we should probably not do this in an interview because it's cumbersome to read. But another way to do this would be to do something like, so we want the max, we can map lambda with the price and some heap. So heap, basically, a heap can give us the minimum really easily, right? If we use a heap, then we can get min easily. And the min that we want in this case here is the value low, the minimum value. And so we can have a function that receives the price value and a heap that contains all the prices before, so that we can extract the lowest value by just doing h0, because that would be, in a heap, that would be the lowest value. And so the way we do that is by saying, when you get a new price, push it to the heap so that we can extract the min one. And so or here is just kind of a way for me to sequence the operations, to do this operation and the one next to it. So, and then I need to return, for this function here, we need to return p minus low. So this is basically minus low, the price minus low, right? That's what we want. And we want to get the max. This is the profit each time. And for all profits, we need to get the max. And so I just need to return this. And low is basically just the minimum value of among the prices, right? And so when we have that map, we need to map it to prices. So that would mean this maps to prices. And just to avoid the case where this here, say for example, if prices is empty, then this here would be empty. And so max, the problem with max is when you give it an empty list, it fails, it throws an exception. So we just need to say, if this is empty, just use an empty list with, just use a list with value 0. And once we get the max, we can just return that. Actually, we can even do something simpler, which is max has this parameter default that can return 0 if this is empty. So it can return the default value if the first parameter is empty. So we can use that. Which one? Okay, so we need to import our heap queue first. What is that? Okay, let me just first print this and see what is wrong. Oh, we need the max. Okay, so nothing wrong with that one. Maybe it's this. I don't know. Let's see. Oh, that would be really weird. This is the problem. That's interesting. Okay, I'm just gonna stop the stream for now, but this is the idea, but I will keep debugging it and post this maybe in the description or something. Yeah. Okay, see you next time. Bye.